Okay, good morning everybody. Thank you to be here. And we start, we're still waiting for some colleagues from Lebanon, but we are quite tight on time, so we start and then they will join us as soon as possible. The first part of the presentation are some technical ones in order to understand how we develop the project and the technical tools that have been developed. And in the second part of the morning, we will see the stakeholder engagement in the different territories involved by the project. So the prompt project is a project related to the preparedness of operational monitoring and prediction of contaminant transport in the sea. And it has been financed in the World Program Union Civil Protection Mechanism. The priority was the fourth priority, the marine pollution, and the action was the external action. That means that the action of the project should primarily benefit an IPA beneficiary country or European neighborhood policy country. So the project had the focus to transfer knowledge and tools to the neighbor countries, and we will see who has been involved in the project. So why the prompt project? If you check out some statistical results about accident and pollution events, you can see that we have a lot of them in the European seas, and especially if you see some statistics, basically all these, the majority of the accident occurs in coastal waters and internal waters, that it means harbor areas. So our focus was try to take into account this area, and the other thing is that, as you can see from the stats, the Mediterranean Sea is particularly subject to this kind of accident because of the high marine traffic, even if it's a limited area with respect to all the European waters. So our focus was related to the Mediterranean Sea and to take into account the events of pollution from chemicals and oil spills. It's as well the Mediterranean Sea. It's a hotspot from human activities and environmental values, and basically all the site that we choose where to develop the project has a really big, an important commercial harbor, really close to high environmental areas with high values. Every harbor has basically a marine protected area in the range of 10 kilometers. So, do we need for this kind of project? Yes, basically we collected some press release of past accident in Genoa, Aqaba, and Tripoli areas. We will see why we focus on these areas, and basically we get quite often release of chemicals and oil due to accident or operations in the harbor. So basically the prompt project came after the first, another project was called Be Ready, and had the focus of to model and give some tools for the prediction of the dispersion of volatile part of oil and HNS spill, develop risk assessment for area spill, develop satellite-based tracking for oil spill, and develop satellite-based tracking for floating container in the sea. And the target area where we developed the project were Genova in the north of Italy, Tripoli, and Aqaba. So one harbor in the, let's say, European countries, and two harbors in the neighbor countries. So prompt made advantage of the results of the Be Ready project. So we just we implemented the system that we already implemented in Be Ready. That was has been developed for the dispersion of oil spill in the water, adding the Genoa harbor and adding the volatile part of the chemicals and the oil spill for Aqaba and Tripoli. Furthermore, we added two tracking algorithm for oil spill, which is quite nowadays a standard procedure, and for floating container, which on the contrary is a brand new tool that basically does not exist anywhere else. So the project involved as a leading partner the University of Genoa, then the Istituto di Idraulica Ambientale de Cantabria that carried out all the development of the DSS, more or less, European Research Institute Onlus from Italy that took care about the communication and dissemination, PM10, WASD, that were technical partners involved in the development of the technical tools that they are behind the DSS, University of Jordan Office de Prosperation du Port du Tripoli for the transfer of knowledge in the neighbor countries. And these are the technical tasks included in the project. Let's say that until the task 3.5, these are all technical tasks for developing of the tools, and then we have the application and transfer of knowledge in the neighbor countries, task 3.6, 3.7, and 3.8. So the project is mainly divided in the development of the tools, the technical development, and then the transfer of knowledge and training in the neighbor countries, and in the case of Genoa, the interaction with the Coast Guard, with the Italian Coast Guard. These are the communication channels where we disseminate and gave all the information about the project. So I will leave the word to the technical speakers, and because we are a little bit tight on time, so I leave the stage to German Aragon from EH Cantabria that will show us the development of the decision super system. Thank you.
Hello, good morning everyone. Thank you for the introduction, and I'm gonna explain a little bit the decision support system that we developed during this project. My presentation has 3 slides only. In the first one, I will try to context the general picture of the DSS, which are the features that we developed, and in the second slide we get into how it works, how these pieces are connected between them, and finally I will jump to my computer to make a short showcase of the DSS. So mainly during the project we implement a new site, the Port of Genoa, as you can see here, and we implement also new high resolutions developments for winds and for currents. So also we added some new APIs to modeling the oil spill on the marine environment, but we added also some new API to modeling the evaporation part of these oil spills, this contamination and this dispersion into the atmosphere. And finally, we rebuilt all the risk assessment that we did because we had new high resolution winds. And finally, also we add to the tool the remote sensing feature to detect oil spill from satellite imagery. Okay, as you can see, Aqaba and Tripoli sites have all the features, and in the third step I will showcase Tripoli site from the application. How it works, this decision support system? Mainly, it has 3 branches, okay? One is regarding the Meteosian data and the visualization. One is regarding on-demand simulation services, which is when we have an emergency, what we can do to add more high-quality information. And also we have one branch regarding the risk assessment, which is really, really great information for planning and to think about how we can prevent and how we can operate when we will have an emergency. So starting with the data, during this project we are not using a daily forecast. We are using a clustering analysis provided by the University of Genova, and we simulate a fixed number of cluster Metosian conditions with the 3D and the Wolf model. Doing this, we have a big Metosian database, and we transform this in several formats to fit our models, and we can visualize this into the DSS. In this part of the on-demand simulations, we developed 3 APIs, one for Teseo numerical model, that is the oil spill model developed at IH Cantabria for our team, one for high split, that is an atmospheric pollution model developed by NOAA, and also we developed an application program interface for the services provided by WASD, who makes an analysis of the satellite images and detect the oil spill and send to us these layers of information. All these 3 pieces works aligned to a daily similarity analysis provided by the University of Genova. What is this? This is that University of Genova every day makes a check of which is the cluster more similar to the current weather conditions. So every day they send us a daily similarity ranking, and we sort all the clusters into the platform for the user to select the most similar weather condition. And finally, we have the risk assessment. This is an statistical analysis. We cross vulnerability maps, taking into account 3 different aspects of the assets: physical, socioeconomic, and environmental, which analyze how difficult it is to clean some physical area, how worse can be the impact in the economic activities of the area, or how can impact in the environmental assets that we have in this area. And we made plus 1,000 simulations per site to make a really big database of oil spills and to have the probability of contamination in these sites. Also, we provide the minimum arrival time of the pollution into the cells of our domains, which is a really good information for planning. And now I'm gonna jump to the computer to make a little. Thank you. No, it's okay. Thank you. Okay. This is the DSS, and let's go to Tripoli. Okay. This is the site. And over here, I don't know if you see my cursor. Yes. Over here we have the tabs for make simulation, that is the one in which we are now. We have the Metosian tab to see the currents provided by the modeling, to see the winds for the different similar clusters that we provide with his similarity percentage, okay? Let's go to the simulation part. We add in this project the satellite detection, okay? So now in this panel we can check what are the days where we have acquisition images from the WASD service. So let's go to day 17th, for example, and let's check which is the information provided by WASD. Obviously, in this day there were no oil spill at the sea surface, so all you can see here are false positive. But in the case of an oil spill, we can declare the simulation as usually do with a release point. But now we can also to make this definition of the release point by a polygon, so we can sit into an area, a polygon, to get a better geometry of the oil spill when it's detected. Okay. Here is the date of the acquisition image, and now to use this module to run a simulation is really easy. We are going to make a simulation over the rectangle. We select the type of substance that we want to simulate, for example, gasoline. We check the volume, and we check the day. In this case, we have to move the time to the time of the image, the acquisition image, which is that's it. We can make a simulation with which cluster. Okay, I'm gonna try with the more similar cluster, that is the 5. We can introduce the water temperature, maybe in Tripoli 28 and 30, density, and the time step for the results. So running this, now we are sending a request to the IH Cantabria servers to run TSEO, our numerical model, to simulate this configuration, and it send us back the results in a moment. The first time it takes a little bit longer, but in a few seconds we had the simulation here. Okay, these are our particles, and we provide a graph regarding the mass balance of the substance. As you can see, we have a huge evaporation in the first hours, because it is a gasoline and it fits the behavior of a gasoline. And we can also check the tracking of the particles moved by the winds and the currents. Also, we provide the surface concentration in the cells. This can be with more or less resolution. As you see, the mass is lost in the few hours because of the evaporation. And these are the main results that we provide. Also, we can do chemical simulations. So we have to click here in this button. We can put release point, select a substance, the day. The process is likely the same. So I don't want to wait for this, so let's go to a simulation that I ran yesterday at the hotel. This one. This one is a simulation of benzene. Benzene evaporates a lot, and here we make the transition from our model TSEO, which is the oil spill pollution model only of the marine environment, to the to fit, and we take the results of the evaporation to fit the high split NOAA model. Okay, so here we have some extra layers that are these ones, atmosphere concentration in kilogram per meter cubic, but we also have the atmosphere concentration in parts per million, okay? So we can see how we model this pollution, okay? Here, with a huge evaporation in the first hours. This accords with also the evaporation that we have in the mass balance of the marine pollution model. And these are all the results for the on-demand simulations. Finally, we have the risk assessment, which is in these 3 tabs. We have the vulnerability maps, which are were produced for each specific site, following all the information collected in the sites by the partners. And we have 3 main aspects: the socioeconomic aspect, the physical, which is literally how difficult it is to clean the coast when an oil spill or a chemical spill reach the coast, and the environmental one, okay? Then we have the hazard. The hazard regards to all these 1,000 simulations that we did. So we have several markers here. These are the release points used and consensus with the partners to analyze the substance and the possible oil spill. So, for example, we can go to main port north or main port entrance, maybe more handy. And here we have the substance that we analyze, and we have our probability maps. These probability maps takes into account all the Methodian conditions scenarios, so you can see several paths. And we can extract also the minimal arrival time of the contamination to any site where there is probability to have contamination, which is really useful information, because you know that in less of 1 hour you can have contamination in all the port, and you can manage your time to response. Okay, and now if we cross risk and hazard and vulnerability, we can produce risk maps. So again, if we go to the main port entrance, we can choose one of the substance and the volumes, and we have all these layers of information. We have an integral layer that is composed by all the 3 aspects that we analyze. We have a physical layer, which is the cross of the vulnerability and the hazard only for physical analysis, socioeconomic, and environmental. And that is all from my side. Thank you very much.
For having my presentation. Okay. Okay. Thank you. So, good morning, everyone. I'm Leone Valentina. I'm a software developer at WASDI, a startup company based in Luxembourg. Today I will quickly present our role in the prompt project, but first of all let me quickly introduce what WASDI is. WASDI is a cloud-based platform that allows experts in the Earth observation field to transform their algorithms in cloud scalable-based solutions. WASDI has a strong focus on interoperability, so all the applications deployed in the platform can interact with one another, and it offers a single entry point to different satellite data providers. In the context of the prompt project, WASDI was involved in the detection and the development of the investigation of how to use Earth observation detection algorithms for mapping oil spills and detecting floating containers in the sea. Regarding the oil spills mapping, our study focused on the use of SAR data, especially those coming from the Sentinel-1 mission. And that's because it's quite the state of the art in the approaches aimed at detecting oil spills in the sea. And that's for the advantages that SAR data are bringing with respect to the use of optical images. Indeed, SAR data are famous to be independent from weather conditions and lighting conditions, making them available independently from the time of the day. So they are available both at night and during the day. And concerning the development of the algorithm, we actually I can still keep talking. So we relied on an unsupervised model which was developed by LIS, which is the Luxembourgish Institute of Science and Technology. The principle lying at the base of this algorithm is that the oil spills in the sea create a smoother surface with respect to the other water that is not containing oil. And this smoother surface reflects the radar signal away from the SAR sensor. And that results in a lower value of the backscatter signal that goes back to the sensor. And here we can see how the algorithm in action. This was a preliminary experiment that we ran over an accident that happened in the coast above Corse. And on the right side, you can see a screenshot of the resulting map that was produced by algorithm when was run in WASDI. And we can see that it replicates quite well the shape of the oil spill in the sea. And here it's how the algorithm was integrated in the prompt DSS. It was already explained in the presentation before, so I will not spend that much time here, but I will just say that there is in the backend of the DSS a client script that triggers daily the execution of the algorithm the algorithm produces the maps, and in that way, those will be available for the client script to retrieve them whenever a user asks for them. And here, indeed, we can see an example of how a map was produced by the oil spill mapping algorithm on WASD, and how the same image is then pulled and showed in the DSS interface. And from this image, actually, there is another consideration that was already mentioned before, and it's about some of the weaknesses that the algorithm still has in over-detection. So, detecting and showing false positives. From this image, it's quite clear that the oil spills maps is a bit too wide for being real. And over-detection is actually still a phenomenon that goes to hinder the performance of the algorithm because of the presence of lookalike, so area that look and behave in the same way of the oil spills in the sea, reflecting then the radar signal away from the SAR sensor. These lookalike phenomenons could be related to low wind area in the sea, but also to the presence of some natural film in the surface of the water, and also to the wakes of the vessels. And the image, actually, it's an image that was shot by my colleague Cristiano Nattero when he was hiking over the port of Genova. And even if probably in the screen here is not well visible, maybe you can see how above the breakwater line there are some area of the sea that are clearly more light blue, and this could be is a good example of the vessel wakes that are left in the sea and that could make the algorithm mistaken in the prediction. The second contribution to the PROM project was related to the detection of floating containers in the sea. That, as Giovanni mentioned, is quite a new field of study. That is important because on average every year more than 1,000 containers are lost in the sea, and this of course comes to a huge impact in terms of the loss of the profit, the danger for the maritime navigation, and last but not least the environmental impact that this could have. So our role here was to investigate 3 fundamental questions. The first one, understand whether or not it was possible from the space to detect the floating containers, then understand which sensors and which data provider could offer the best potential in terms of availability of images, and third objective, to understand if it was possible using the satellite images to automatize the detection of the floating containers in the sea. This comes, of course, with some challenges because floating containers are relatively small objects with respect to other objects that could float in the sea. They are constantly moving, so they don't have a fixed position, but their position is depending on the movement of the sea. And then there are also some constraints related to the data acquisition because of the resolution of the images could not be enough for detecting these containers, and on the same time the cost of having very high resolution images could be high. To investigate our questions, we set up an experiment in collaboration with the port of Tripoli, where 2 containers were deployed on close to one of the breakwaters in the water of Tripoli. As you can see, 2 floating containers were deployed, being anchored in a way that we could know the exact position of the containers and then know where to look at these containers from the space. Given this experiment setup, we then started looking for satellite images where the containers were visible. And we first started using public data from the Sentinel missions. But the resolution was not enough to actually find the container and see them on the images. So we have to change our strategy, and we had to rely on some commercial data providers. So here our strategy was to set up a data set of satellite images, trying to have a very diverse set of images, both from optical and SAR sensors, and targeting both images from the archives of these data providers, but also trying to acquire some images from some tasking acquisition. Overall, we put together a dataset of 36 images, and here I will quickly show you some of the images, starting from the optical ones and going from the ones with less resolution. Here, for instance, we see the planescope images with a 3 meters resolution, and we can see that the containers start to be slightly visible. So going on with a higher resolution with the SkySat images, we see that the containers start being quite well visible in the sea, and the visibility of the objects goes even higher with the images of the Airbus Pléiades constellation, where the image looks very neat. Here it's a 30 centimeter resolution image where we could clearly identify the containers. However, we were not that lucky with SAR images. Indeed, with some tasked acquisition, we could not always find the containers in the images, even with a higher resolution with the 50 centimeters one. And that's because for the budget constraints, we decided to go for single look images. Most probably having the possibility to go for multi-look images, the containers would have been more visible. But this could be for another project. With our dataset of 36 images, we then try to apply on them some machine learning algorithms to see if they could detect the containers in the scene. We adopted 3 approaches, one of relying on the well-known k-means clustering, another one relying on the segment anything model released by Meta, and the third one was a combined approach where we applied both the algorithms and we marked a container as detected if either the k-means of the segment anything model was actually detecting the container. The results show that none of the 2 algorithms were performing better than the other, but the combination of the 2 of them gave us some good results. However, even here, we of course faced some challenges, and some of them are depicted in these slides. Especially for the segment anything model. Indeed, sometimes it struggles to identify the exact border of the container, as it's shown in the image on the left, where the container on the lower part of the image is not correctly shaped by the bounding box provided by the model. In the image on the center, indeed, the model confused the shadow created by the container with the container itself. And then in the third images, instead, we can see how a low resolution of the image could sometimes bring to the impossibility to detect the containers. To conclude, overall, we can see that this experiment that was, of course, limited and put in very simplified conditions, having the container anchored in the port, The detection of containers from the sea seems as a feasible possibility, especially when the detection algorithm are applied to high-resolution optical sensors. So we think there is room for investigating more the task. And that concludes my presentation, so thank you.
Thank you very much, Valentina. So this is the first part that was dedicated to the technical development of the project. If there is any question, any comment, if there is any curiosity. If not, we can, yes.
I'm a software engineer, so I'm not specialized in the field. But I think that again the data set was very limited, right, in size. So I think that thank you. So the dataset was very limited in size. So for sure, having the possibility to experiment with with more data, for sure can help us to advance and see indeed how we can improve the predictions. Also, as I mentioned, SAR data, I think, could be, in the same way, are useful in the oil spill detection, could maybe help also in the detection of floating containers if the images, we can rely on multi-lac images where the noise is less visible, and so we can have more high-resolution images there. So, yeah. I think more experiment and a wider set of data. For sure, also here we adopted unsupervised models because there is no availability of labeled data. But another area of investigation could be try to populate some labeled data set and then try maybe some supervised algorithm that maybe could also help.
Yes, please.
Thank you for presentation. Are you planning to continue this work in your organization on your own, or are you dependent on projects and funding from outside? And are there any plans to actually apply this in real case scenarios? Because I think we have plenty containers floating to be potential subjects for investigation. Thank
you. Well, of course, it would be interesting to continue the experimentation. On our side, of course, we would need still some partnership with some research center. We have our scientists in the company, but the resources are limited. So in terms, especially of time, with respect to other projects that we are also developing. So of course, it would be interesting to continue experimenting on this. With some partnership, though. So, as it was done in this project, continuing collaborating with other research institutes.
If I may complete the answer, actually, when we began to work on the subject, we realized that there is anything around. So it's just a playing field to develop some tools, and we found out why, because actually the resolution of the image for the free one is scarce, and there is another problem that when you lose container, basically then you don't know where to find them, and so to acquire all the high resolution image is quite a heavy issue. So basically we performed the experiment in order to have a milestone, something that we know how all the detection and satellite image performs with object of such a limited dimension. So I think that there is space to develop more this issue, and actually as soon as we began to work on the subject, we began to receive advertisement for tracking containers. So I think that there is a high request of the subject, but on the terms of satellite remote system detection, there is still a lot of open field to develop products. There are other comments, other questions? Okay, if there are not any other comments, I will make a little break of a quarter of hour, and we can meet and start again with the knowledge transfer and application in the pilot sites. Thanks. we shall going on with the stakeholder engagement and transfer of knowledge. So we will listen our partners from the neighbor countries, and then we close with the case of Genoa. So I will invite OEPT, then University of Jordan to present us the activities done in the project. Thanks.
Good morning to all partners and participants. I'm Habiba Al-Ghor from the port of Tripoli, Lebanon. Today I'm presenting a brief introduction about the port and its role in this project. So Tripoli port is one of the most important ports on the Med Sea. It occupies a strategic location that connects the Aegean East to the European West, and the close proximity of Tripoli port to the Suez Canal. It's only 300 nautical miles. And according to recent statistics, for the first 4 months of 2025, around 272 vessels called at the port. Now the role of OEPT in the project. So OEPT has carried out several activities during this project. We will start with the experiment of floating containers that was with the collaboration between OEPT and WASDI. And satellite imagery were used for containers detection. And the containers were located 140 meters from the secondary breakwater. Two containers were used during this experiment. The blue one was submerged partially and the red one was afloat partially. So the stakeholders engaged in this experiment were the pilot station and the port workers and interns from the university, Lebanese University. And now we will move to the weather station software. It's a MedPack software purchased during this project. Sorry. So the data could be downloaded in graph or in table, and it is exported in CSV format, and the measurement intervals are either 10 minutes or 1 hour. And the parameters measured are temperature, humidity, pressure, precipitation, wind speed and direction, and wind gust speed and direction. So this is an example table of 9 June 2025. And this is the same data but in graphs. Now we will proceed with the ADCP, acoustic Doppler current profiler, that was located 9 meters below the water surface. Also an ADCP software were purchased during this project. So it measures the current velocity, speed and direction, current and water depth, measures also the temperature of seawater and pressure depths, and indicates the presence of tides. So here is the graph downloaded from the software. The first one represents the water speed, and the second one the water direction. So at the surface, the water is influenced by the wind direction, and as we go deep, the water movement will be influenced by the three main forces, which is the Coriolis force, tidal force, which present the periodic variation in wind speed and wind direction, and also the gravitational force. And now we will move to the last activity done during this project, which is the EDSS workshop. So in 27 May 2025, IH Cantabria has trained OEPT staff on the usage of the updated version of the EDSS to be able to train the Lebanese stakeholders. And on 3 June 2025, OEPT has made the workshop in the aim of introducing the EDSS and provide the stakeholders with necessary skills. So the stakeholders involved were Lebanese university students, the urban community Al Fayha, and volunteers from the port. And the number of attendees reached 13. Now the workshop was divided into 3 main sessions. Session 1 includes the pre-test and made for the attendees, and a PowerPoint including an overview of Tripoli port and the project. Also the importance of EDSS role in managing the marine incidents, mainly all HNS and volatile pollutants, and overview of the EDSS and its main components. Session 2 consists of a detailed explanation of the EDSS and key aspects with functionalities and examples, and also a presentation of the recorded video. And the session 3 includes a Q&A post-test for the attendees with answer correction, and a final discussion. This is an example of the post-test, attendance sheet, feedback, certificates. Okay, and in conclusion, integrating data from the software, weather station software and the ADCP software, along with the skills acquired from the experiment of floating containers and the EDSS workshop, enhance our ability to respond effectively to the marine pollution, in addition to empowering OEPT staff and strengthening the emergency response team and enhancing the port's contingency plan. So for future plans, as a BRAD project has been developed into prompt project toward port sustainability, OEPT is currently working with a global quality certification. It's an ISO certification body provider on the port air emission assessment. So in the future, OEPT is planning to integrate the prompt project concept within the study to assess the volatile pollutants emissions from oil and HNS spills. Also to maintain a long-term collaboration with prompt partners. A project like Aware Cost have recently been submitted, led by the University of Antwerp and involving University of Genoa, IH Cantabria, ARI and OEPT. So these projects support future agreements and MOUs with international ports, such as the one recently signed between the Port of Antwerp and the Port of Tripoli. And thank you.
Good morning, everybody. I would like first to thank all partners of the PROMET project and also participation. As a partner in this project, I would like first to introduce a profile of the University of Jordan. University of Jordan is the first national university in Jordan. It's established in 1962. It's the largest and oldest university and offer a wide range of undergraduate and graduate programs. And of course, it has a good ranks according to QS ranks, which is 324 in 2025. There is about 24 schools offering about 205 graduate and post-grad programs. They have different discipline of faculties or schools like science, medicine, engineering, and etc. Strong focus in research, and they also allocate a good budget for funds for research projects, and they have a good collaboration in different discipline in science, for example, and medicine, and different aspects with international and local partners. Research centers in the University of Jordan also has a good concerns on the administrative of the University of Jordan. We have different centers that concentrate on the research. I will mention the last two centers, or school and center in Aqaba, where they place the implementation of the project. We have School of Basics and Marine Science in Aqaba branch of the University of Jordan, and Marine Science Station also, which is established in mid of 17th, which is mostly 50 or more than 50 years. In Aqaba, the branch was established in 2009, the University of Jordan Aqaba branch, and the School of Basic and Marine Sciences, it was one of the established faculties in this branch. Marine Science Station, as I said, established in mid of 1970. The objectives is mainly to serve as marine research facilities for scientists in different levels and in different regional and international countries, provide a hub of international scientists to study the tropical and subtropical marine ecosystem. The Marine Science Station and the School of Marine Science, Basic and Marine Science, we have long history of collaboration and promote, and before BRD is one of the examples that we have good collaboration with the Mediterranean countries and different fund agency, basically, but EU is the main hub for supporting the joint projects from Mediterranean Sea in the north and the south. Our role, of course, we have different roles in this project. First of all, to provide the information regarding the model to be used, such as the weather station, weather information, water currents, and in terms of speed and direction, and also sharing in all the activities like the interim reports, periodic meeting, and final reporting. Also, we are involved on all the tasks, but mainly we are concerned about gathering the data that used for implement the model, the EDSS. Dissemination of any activities as University of Jordan as a partner, we have different platforms to disseminate the projects, such as in the university website, the official website of the university, even in the Facebook, and also here in the different Twitter, like Twitter, and also in the audio of the University of Jordan, and in the University of Jordan website, official site. And the same thing here. This is the last workshop that performed in Aqaba. The implementation or the gathering of the information in the Gulf Aqaba, I would say that Gulf Aqaba is a unique Gulf. It is very deep and very narrow. It's only 100 kilometers long. The Jordanian side of the Gulf Aqaba is about 27 kilometers only, which assumed, or it is the only outlet for Jordan to the ocean. So the government is concerns a lot for this region in order to keep it in running well, because it's assumed to be the most important economic resources in Jordan. The ports is the one of the important spots where we have three sides of the ports. We just they have pointer. There's no. Oops. Sorry. sorry. Okay, I can keep. Yeah, you can see this is the Jordanian coast, starting from here up to the south part. All these 27 kilometer has a lot of activities, different activities, like resorts for tourists. We have the protecting area, or the marine protection area, which is has the about 7 kilometer and passes through the MSS. This is the Marine Science Station. And we have in the south also some resource area, and also we have the port area. So the main port is in the south. Really, the authority in Aqaba, the Aqaba Special Economic Zone Authority, managed to reallocate all the old ports, which was here was the industry port or phosphate port. It's reallocated and moved to the south in order to keep the north region out of any activities of ports, in terms of keeping the any accident could happen to be far away from the urban city, which is here. So the planning in the region is very good in Aqaba, and the same time is very sensitive for any pollution because it's semi-enclosed. Any pollution is really inserted or happened in the Gulf Aqaba, it will remain inside and also will move all around between the 3-4 countries, Jordan, and also in the other side, in the west or in the south. So they will move around all the countries. So it's a joint benefits to having such as this project in order to promote it and use in order to predict any scenario of pollution. In Marine Science Station, which is here, we purchased acoustic Doppler current profiler, ADCP, for measuring the current speed and direction in order to provide the model of this data, and also weather station to collect the meteorological parameters, which we employed, or we deployed the ADCP somewhere in front of the Marine Science Station as a representative region. Here's some just picture for the meteorological station that purchased through this project and also installed in the Marine Science Station. These are some data for specific period. For example, the wind speed, wind direction, and will give us information how the dominant or prevailing winds in the Gulf Aqaba mostly is coming from the north, and the speed is ranging from 0 to 10 meters per second. This information is very important in order to make a good prediction. Air pressure, we have air temperature, and relative humidity. All these data is continuous recording each 10 minutes, and we deploy it every several times in order to provide it with to our partners in order to insert it inside the model. This is not the only data that we have. Before we do that, we we do have information about the weather station since in 20 years. But this is very important to make calibration, and also in the time of running the period of the project itself. So the database is good, but you need to have the data in the same period during the implementation of the project. The ADCP deployed in this region in front of Marine Science Station in different, of course, period during the time of the project. I will give you some information. Here we deploy it using divers, or by our divers. This is an example of the outcomes of the current speed, and we analyze this information in order to understand how the current is really behave. And you can simply see that the speed has a periodic change from weak to strong, And if of course this is related to driven forces that occurred in the Gulf of Aqaba, like the wind speed and also the effects of the tidal current, and of course the Coriolis force exists all the time. And we have here the direction. Even so, the direction is also, we have fluctuation change in the direction, and we have signals. The change in speed and direction is about 12 hours and 24 hours. This is really related to the effects of the tide current, and also at the same time the Coriolis force in our region has a period of 24 hours. So both are superimposed to having the periodic of change in speed and direction, and this must be taken into consideration in order to understand how is the pollution as prediction. It could be moved like back and forth, but in general they have a trend current. So the trend current is follow the wind direction, but during the flow with wind direction, there is also, back and forth motion or movement of the current. The workshop held in May 29th this year in Aqaba in order to disseminate the outcomes and also to show them the tutorial video for EDSS. We invited the stakeholders in the region, and we have of course disseminate or send the invitation letter and have this agenda for the workshop. And of course we print or prepare the fact sheet, and we include the Arabic in order to people understand exactly when they read it to know what's the outcomes or objectives of the project. There are some pictures. We present them the information about the projects. And also, Dr. Rashid, he's my colleague in this project. He also, before that, he presented them the basic information about the chemicals, pollutions, and all pollutions, and what is the impacts on the marine and also in the environment. And here, of course, Brima, our colleagues in the projects, I make the video for the audience in the workshop to understand, and also I translate it as much as I can in Arabic for them to understand what the details of the model. And at the same time, I present the model live to them for the Gulf Aqaba, and we make different scenarios, which was really very impressive for them. And the representative from the stakeholders, they really understand what's the importance to involve this kind of program in their real, process. And this is in the very near future. I think we can soon let them take decision that this can be as an guidance and help to understand more before any accident happened, or at least if it's happened, they can understand how's the fast process they can take and where the location it could the pollutants go. So this is fast response should be, and they see the results very interesting for them. I believe it will continue to support them for the information more if they need. I will keep, of course, visiting them. I mean the Aqaba Special Economic Zone Authority. This is like a governor body in Aqaba, in order to include the platform or the model in their process for fighting oil pollution. Our stakeholders that involved in the workshop and before the workshop, we have our collaboration, because Marine Science Station is very important in Aqaba. We have MOU with most of these stakeholders as scientific research center, that we do the program for monitoring program for most of these bodies or entities in the Gulf Aqaba. And that's all what I can say, and thank you so much.
Good morning again to everyone. We have already heard that ports, especially in the Mediterranean Sea, are areas of high traffic where most of the maritime accidents occur. According to the EMSA, the trend has been stable for at least over a decade. And we have two options to mitigate the risk associated with spills. One is prevention with measures like safer navigation protocols or swift to cleaner fuels, or preparedness. Be ready when one spill does occur. Focusing on the port of Genoa, there in the picture, I would like to do a step back and explain you how we build a tool to predict the fate of a spill in a timely and reliable way, our goal down in the blue box. Actually, to deal with this kind of processes, only two pieces of information are needed: the releasing position of the substance and the velocity field, that is the currents that move the substance in the sea. Obtaining the velocity field requires us first of all to characterize the meta-ocean variability, so tide, wind, wave, regional currents, and our approach to do so starts from an extensive data set, 40 years of hourly and wind wave, defining the whole Mediterranean Sea. You can see a zoom in the Ligurian Sea, where we have a data set in correspondence of each point. We select the one of interest, the green one in this case, and through an algorithm, the 30 years data set is broken down week by week. Of course, it is not that every week refers to a unique sea state. There are repeating patterns. Just to mention one, in the Ligurian Sea, extreme events are almost always associated with southwesterly waves. So we group the weeks into distinct patterns. Then from each one, we select the most representative one, obtaining in this way a limited but comprehensive set of scenarios, with wind and wave from our hindcast, regional currents and tide from some external reliable providers. And this clustering step is critical because most of the computational effort in the whole workchain is in the next phase, the hydrodynamic modeling. A hydrodynamic model integrates the environmental variable to calculate the velocity field. So now we run a model for each of the pre-selected scenario, obtaining in this way a library of velocity field that are ready to use to quickly run a dispersion simulation, as quickly as German showed you before. Okay. Dispersion model takes into account both the velocity field, so the currents, and also the physicochemical characteristic of the substance. In fact, once both oil or HNS are released into water, they undergo several processes that are sketched in the image on the left. And actually, these processes are solved by the model under the hood, so you don't really need to care about them while you run your simulation. Let's do an example, making a simulation for each scenario with the same configuration. So on the right, you see the releasing position for oil on the top, HNS down. Oil are released on the main vessel route, two different type of oil, HNS in correspondence of two chemical storage sites in the port of Genoa. Here are the results. On the left, the weathering module results. So, for example, on the top for the automotive gasoline, which is a light fuel, you can see how evaporation, the green line, dominates. About 80% of the fuel evaporates after less than 10 hours. Differently, ethanol down immediately dissolves into water before slowly evaporating. On the right, you see the hazard map. Again, for the oil on the top, HNS down, which tell us the probability that the spill will reach a different location. Now, given the configuration of our spills inside the port, most of the substance will either evaporate or adhere to structures like breakwater and docks, remaining at the end inside the port. This could cause local water quality degradation, potentially affecting the marine ecosystem, but it also allows for targeted and specific cleanup operation. So given that most of maritime accidents occur in the port, we really need a structured workflow to be able to predict the fate of the spill in a timely way. I think what makes this approach powerful is the way we have condensed 40 years of variability into a limited number of scenarios, in this way making the whole system fast and accessible. The final step is a web-based platform. We have already seen this in very details, to allow the user to run its own simulation. And this is what we showed to the Italian Coast Guard at the port of Genoa about 2 weeks ago. So the Italian Coast Guard is the authority responsible for real-time spill response. Up to today, whenever there is a spill, they receive a call or a report. They send a team there to verify it. And if confirmed, they activate all the mitigation procedures, like they deploy containment booms or skimmers or chemical dispersant. And at that stage, they make quick judgments about where the pollutant might go next, based on wind forecast and mainly on experience-based knowledge of currents and port dynamics. So as you can see, this approach relies heavily on intuition and experience of the officers, which is extremely valuable, but maybe sometimes also limited, especially when conditions change rapidly or involve substances with complex behavior. So we spent one morning there showing them how to run a simulation, interpret the results, and adapt a little bit the tool. They also gave us some hints, some integration they would like to have, which is good, another reason why we went there. They have this big monitor with an interactive map where they can see in real time ships entering and leaving the port. And they already draw on this map the boundary covered by the domain to remind them that there is also this option. If they need it, they just have to Google it. And that's it. If you have any kind of questions, I'm here. Thank you.
Okay, thanks for the presentation. There is any question about this section? Any comment? If there is not any question and any comment, I will leave to Ebrima the final part of the event with the concluding remarks and closing remarks.
Okay, so I'm going to take you to the communication and dissemination activities done from the beginning to date, and which is responsible by ERI. So here you can see we first created the logo of the project, which depicts exactly the whole concept of the project. And you can see the box here implies the containers, and the blue, which the water and also the air, and the star mark, which implies that yes, the prompt and it has started. So, so the communication and dissemination overview. Here are the objectives, and we want to raise awareness among stakeholders, relevant stakeholders. So we did that We've been doing that from the beginning. And of course, to help doing this thing, from the beginning, we have a communication and dissemination plan that we created from the first 3 months of the project. We highlight like a roadmap, which gives us a roadmap of what the target stakeholders, and highlight all the content necessary for us to carry on the dissemination and communication activities. So we want to engage stakeholders also. Target groups promote the project visibility and enhance project replicability and sustainability. So these are the main objectives for this work package. So the strategy that we deployed. So you can see here, we told like the ports, the civil protection authorities, researchers, and NGOs are the main or are the key stakeholders in this project, and these are the target audience. And that's why from the project we have different ports. We have 3 ports in the project, and that is Port of Aqaba and Port of Genova and the Port of Tripoli. So these are the 3 ports that are involved within the consortium, but also we extend our tentacles beyond that, reaching other ports that are within the European zone and also the neighborhood. So we deployed these channels. These are the channels that we deployed to reach these audience. And there are one of them that is very fundamental, which is the UCPK, Union Civil Protection Knowledge Platform, which have been suggested or recommended by the contracting authority, which is DG ECHO, to make sure that all the activities of the project are being published there. And we follow that. We've been publishing so many activities there and results. So we also leverage the social media platforms, and that is Facebook, Instagram, and X, also LinkedIn. Online training also, we also did that. And during these trainings, we train the end users, which have been presented anyway. Workshop also, from the workshop also, we try to disseminate the project results and outcome. Stakeholders also roundtable event. Through this event also we did, of course we reached so many stakeholders through this event. And communication and promotional materials, so which involve of the whole materials, as you can see from today also we brought some of them. And that include like the project fact sheet, infographic, and also the roll up and depends, and all those things are under this category: communication and dissemination promotional material. So those are the channel anyway. So the results here, you can see the dissemination results. At least we made 46 publications on the UCPK platform, but also 206, at least 206 posts on the social media platform: Facebook, Instagram, X, and LinkedIn. We train, of course, 3 ports, which also regarding the functionality of the upgraded EDSS, which is the decision support system. And these 3 ports, of course, are from Jordan, Lebanon, and Genoa. So we conducted also 3 workshop events and then also an online training session. The workshops are basically the national events being conducted in Geneva, Lebanon also, and then Italy. So that's one of the results. And we also have like the stakeholders that we engage during the phase of this project. At least 12 main one. And these stakeholders are within the category of the target groups, mainly ports that have high interest or very relevant to the concept of or to the findings of the project. At least 500 communication and promotion materials also were produced. So the total meetings that we conducted in general were 4 in person and 1 online. The 4 includes like the kickoff meeting, the advancement meeting, and also we have a meeting also in Spain, and of course this one. So the online meeting that we had was during the COVID-19. We could not go to Lebanon or Jordan because of the political instability, of course. So that's why we held that online through that meeting through online. But actually, originally, it was designed for us to go there. So of course, but in our quest to reach the relevant stakeholders, also we prepared a 15 minutes video tutorial EDSS, which summarized the functionality of the EDSS that was used or leveraged by partners in their national events. Of course, as you can see that it was even presented. At least 30% were trained in total as far as this project is concerned. And these are the key stakeholders or key members or end users of the project that were trained, and we made sure that they understand exactly the findings of the project. And also basically to use the EDSS, which is very, very important for the sustainability of the project. So those are achieved. And to list more, also we have the stakeholders that we engage as far as the project is concerned from day one. Of course, we know ports are main stakeholders, and Port of Tripoli, they are beneficiaries of the project. Port of Aqaba, Port of Genoa, Tripoli Union municipalities during the national events that was done in Lebanon. The Lebanese university students also were involved. National event Lebanon, Jordan Maritime Authority, national event from Jordan. We also have the Marine Science Stations, which is during the national event in Jordan. University of Philadelphia, national event in Jordan. The Royal Marine Conservation Society of Jordan, national event in Jordan. Port authorities, port volunteers, they are also, of course, relevant stakeholders here. They were engaged during national event in Lebanon. School Basic and Marine Science were also involved during, and also Servicio Nazionale della Protezione. They are also very important or key stakeholders, and they were also engaged. Well, they have been engaged anyway. Also recently, during the kickoff meeting, also we invited them, and they were there, and to witness all the activities of the project. So here is just some demonstration of the workshop was held, and that is in Jordan, Lebanon. The round table discussion here during the kickoff meeting, when we invited them, and then we were engaging them by revealing the concept of the project also, and also give them chance to talk about what their expectation of the project. We don't do it only on this kickoff meeting, but also the subsequent meeting we held. But they were also part of. So we were conducting stakeholder roundtable. So here is the demonstration for the online training session, and here visibility, some kind of pictures for the visibility of materials. So the key takeaways. So what do we take away from this meeting as far as PROM is concerned, which today marks the ending of the project formally. In terms of innovation, I would say prompt tools, which is the DSS, and which incorporate the satellite detection of containers, satellite detections of floating containers, are very, very important key in terms of marine pollution. And this is an innovation, it's a key innovation aspect of the PROM project, because it's been, it's not something that is common to have a unifying platform which encompasses the ports and can able to respond to marine pollution in real time. So I think this is really an innovator or an added value to the Mediterranean Sea and also within the European neighboring countries. It's very important to involve Jordan and Lebanon as far as EU is concerned, because it's a way of like aligning with the policy of the national neighboring countries, which is very fundamental. But of course, you know that PROM also it's aligned with the SDG 14, protecting life below water. It's really a fundamental step taken to make sure that all life below water are protected, and they are protected from these oil spills, which is very a big threat. Of course, from our presentation, you can see that it's been highlighted that so many incidents happened between the past years, and they are a threat to the life below water. So this is an innovation step, I could say. So the impact here: improve preparedness for soil for oil and HNS, that is hazardous substance spills in ports. Yeah, of course, because we have trained a lot of end users. We also we established the EDSS and also incorporate the satellite detection system. And we trained them, and as you can see that from the presentation, we are going to scale up that activity, and which is very fundamental. If all the ports within the Mediterranean Sea can leverage this kind of system, I think response to oil and spill within the sea, I think it's going to be really enhanced, in my opinion. And that is the impact here. That's the idea, just to make sure that actions are being taken on the right time, to make sure that it doesn't affect life below water, which is because we are part of the ecosystem. In fact, protecting them are fundamental for our planet, for us also. So the scalability here, I would say, solution adapted by the other by EU, which is the partners within the EU, and also the neighboring ports, which is Lebanon and Jordan. So here, that adoption of it, I think it's going to play a key role in scaling up, because as you can hear from other presentation, that the concept of prompt will be scaled, and it will be advanced for future projects, and that is inevitable that we will do, but within also the consortium. So the sustainable part of it, yes, it's very important, and I would like to double click here. In fact, that UCPK platform, it's one of the platform that we rely heavily for the sustainability of this project. And if you want to know anything or details concept of this project, you can freely go there. You can just click in any time, any moment. You will have all the data that is necessary for this project, because we have an extensive publication of the project activities, deliverables, outcomes, and also the results. So we leverage that, and the integrated EDSS interport operation also, of course, it's a way of enhancing the sustainability of the project, as I already alluded. The future call for proposal, of course, we're not going to stop here. Prompt was an extension of a previous project, which is Be Ready. So, and we are not going to stop on prompt. I think we will extend the concept for other proposal, as far as funding is concerned. So what are the next step here? So what we're going to do as a consortium here, we will publish a layman's report. Layman's report by summarizing the concept or the outcome of the project in such a way that somebody who is not an expert in this theme or in this domain can able to read it and understand it, and can able to be aware, because the sensitivity also, the awareness sensitivity here, it's very paramount. So we're going to publish that by the end of this project, which is the end of this month. So we submit final deliverables, of course, that are remaining, and then we pursue calls to advance the prompt. So these are the three things that we will do as a next step as a consortium. Of course, we've already submitted, in fact, one of the proposal, which is under the same program, our course, and it is just basically the same partners that are here, and it has to do with sensitization to the population, to sensitize the population about marine pollution. So something that is similar to basically the concept of the prompt. So that's the end of it. Thank you for your attention. And if you want to know more details of it, you can just access this thing from the UCPK network platform. Thank you so much. If you have any question, you can ask. So in the absence of any question, I think the closing remark would be from DJ Echo.
Thank you. Since have not I have not prepared any special speech, I will remain from here to be very informal. But thank you very much for all the work in the past 2 years. And just to start with, I would like to maybe have a quick word on what DG ECHO is for those who don't know and why we fund these kind of initiatives. So DG ECHO is one of the Directorate Generals in the European Commission. It's about civil protection and humanitarian aid operations. And this specific fund for these kind of initiatives is coming from the civil protection side of the house, where we concentrate on prevention, preparedness, and response to natural and human-induced disasters. So the goal here is actually really to make a difference on the ground or in the water, for that matter, not on paper alone. Yeah, so we don't orient our funding for research or development. We orient funding for research and development that ends in actual end users' hands. And it should make this real difference, and it should reach those end users, and it should reflect the needs of the end users, right? So that's why we always encourage from the very start to look around at the stakeholders, at the national civil protection and maritime authorities, to see where they stumble, where they have difficulties, needs, where things can be improved, and to meet them halfway with new technologies, with new research. So we're looking for these partnerships that can improve and really make the difference, because I attend regional agreement secretariats meetings, not secretariats, the meetings of regional sea conventions in the Baltic Sea, in the North Sea, and in the Mediterranean Sea, where national authorities represent their countries and bring those issues, raise them, and discuss and look for solutions. And very often, what I hear there, they don't have enough human or other capacities to go and do more research, do more developments that could actually help them in response to pollution at sea or in the ports. So there is still a gap between research, between universities and between end users. And we're trying to somehow make them connect. And these projects like yours allow us doing that. But I think we can still try to improve and to do better in this connection. So just to give you an example, for instance, the Bonn Agreement, the North Sea countries, on their website, have published a list of regional priorities where they are looking into possibilities to connect to researchers and in universities that can help them out with this. And one, if you read them, they don't have too many. They boil them to, I think, currently 7 maybe. And one of them is also what you were doing here is floating containers and detection of them. So there is a need maybe broader than you even have already reached out with the deliverables of this project, and there may be a potential still to connect to others who would like to continue this or similar work. So this is one thing. The other thing, I would like to really congratulate you again on the work done. And I hope that these connections, these networks that have been established during the project will continue, either in other projects or without other projects. Because just to let you know, that also in DG ECHO we receive a big number of projects, many, many more than we can fund. The competition is fierce, so to say, because more and more organizations know about this possibility. However, the funds stay limited. They don't grow as fast. So therefore, we encourage those, especially those who want to continue with their work in other projects, please bring us the outcomes of the previous projects. You mentioned the Union Civil Protection Knowledge Network platform, where you publish your activities during the project. Please also don't forget it after the end of the project. Bring what this project has made, what kind of difference has it made? Has the DSS been adopted in 1, 2, all ports? What exactly has it changed? Has it been used in any specific real case scenario? Show us that whatever you developed really made the difference. And on that basis, we can see, yes, these guys are doing well. They are really making worth of the taxpayers' money, and we would like to support them in doing further good work. So with that, thanks again, and who knows, maybe we will see each other in other projects.
Okay. Thanks a lot, everybody. If there is any question or comment, a final comment. If there is not any question or comment, I would... yes, Brima. Yes, if you can please sign the attendee list at the exit on the way out. And I would like to thank you everybody online and on presence to attend this meeting. And I hope that we can work together again with the partners of the neighbor countries. It has been a pleasure. It has been a pity that we could never visit you because of different reasons during these two projects. Thanks everybody, and have a good day. Thanks. Bye.